Okay, hi everyone. Happy to see the energy still up at day 2 in PythonAsia, no? So, welcome to my talk on test-driven golden paths using Python to validate backstage internal developer platforms. So, first off, let me introduce myself. Hi, I'm Arnel Sarmiento. You can call me Nel. I'm from Davao City, Philippines. I work as a cloud DevOps engineer and Python developer for several multinational organizations. I have four AWS certifications under my belt, and I'm also part of the AWS Community Builders program. And I also lead Durian Pi, Davao's Python user group. So in Durian Pi, we do meetups, workshops, and PyCons to essentially elevate the state of tech in Davao City, right? So if you're in Davao City, feel free to reach out to me. Maybe you can join a meetup just around the corner. All right. So for this talk, I'm going to walk you through the age of DevOps currently and the slight problem of the increased developer cognitive load. I'm going to walk you through what platform engineering actually is, the concept of golden paths and why they matter, and I'm going to introduce to you a simple tool called Backstage. We're also gonna walk you through how to really test the Backstage and how it actually drives golden paths for many organizations, some benefits, trade-offs, and when this whole setup actually makes sense, right? So I'm going to walk you through with a situation. Let's start with someone I think most of you know. Maybe her name is Maya. Maybe it was you last month, right? Maya starts the week with what sounds like a normal assignment. Build a small microservice within the sprint. So it could contain an API, it could access a database. Database might be existing or she might spin up a new one. She still doesn't know. It might contain some background jobs, things like that. And the team might be composed of a front-end developer, a back-end developer, a product manager, or maybe an engineering manager, right? Simple stuff. So Maya expects that the week would start like planning the feature, building the service, test it, deploy it, learn from what happens, look into the observability of things, and repeat the process, right? So that's the promise. But for the first hour, it goes somewhere else. Not into the code, not into the actual feature, but into these sorts of questions. What is the standard that we're gonna build for this service? What framework are we gonna use? Is there like an existing template that Maya could just derive from? Where do we store secrets? Is it in a cloud service provider? Is it somewhere else? How do we deploy this? Who owns the service that my service depends on? Which team does it belong to? What alerts are required? What security checks do I have to set up? Where are the documentations? And all of that. So the problem begins with these types of things. The tools are actually there. They're not missing. But there's really a missing path on how we can actually go ahead and find those tools. So by midweek, Maya has been busy but not productive. So she's been in the docs, she's been in the Slack channels, old repos, examples, and messaging people in meetings. And she finds one example service and someone, maybe her senior, tells her that don't use that, that's an old one. And she finds another one but lacks some observability patterns. And she finally finds something that maybe matches what she's looking for, but unfortunately, the person who owned that service resigned 6 months ago, right? So she has to look into the documentation. So it's a problem. Now she's not building forward, she's actually triangulating. Uh, Not because Maya is like a slow developer, not because she lacks the skill, but there is a missing path into finding these types of tools. So while Maya is trying to piece all of this together, she finds out that other teams does things very differently. There might be other teams that works in growth, in payments, in support, that works on different tooling for different use cases, and she really can't figure out where to start. So this is the issue. The organization is not really empty-handed. The tools exist. They have the cloud adoption, they have the CI/CD, the observability tooling, and in a way, we are missing a certain layer into figuring out how can we easily adopt these sorts of things. So this is actually connected to the promise of DevOps, right? Where we want to really break silos, shorten feedback loops, and bring teams closer together. So that shift is really important. It moved away from a world where developers threw code over like an operations team and then hope for the best to make that it will run properly. But in many organizations, so what happened next was incomplete. The silo was reduced, but the path was never made clear. Responsibility moved closer to the developer, but the knowledge, the guardrails, the paved road did not move with it in a usable way. So you can see a higher level of cognitive load passed over to these developers in trying to figure out how can I set up these infrastructure stuff from scratch. So that's where the concept of platform engineering comes in. Not just as a not, this is not a rejection of the concept of DevOps, right? Not a replacement, but building on top of it. So what we can see here now is that we give teams shared ownership without forcing every individual engineer to reconstruct the entire operating model of their infrastructure from scratch. So essentially, it will, the ultimate goal here is to reduce developer cognitive load. Especially if you have like an infrastructure of this complexity, you're working with Kubernetes and you're trying to figure out all of these sorts of questions, right? So what's missing here is actually a middle step, a self-service interface that will essentially abstract away creation of these setup. So this is what we call an internal developer platform, or some people call it an internal developer portal or an IDP, right? So I'm going to showcase how we're going to build an IDP with a very well adopted tool called Backstage. All right. So Backstage is an open source framework for building developer portals. It's an incubating project by the CNCF, the Cloud Native Computing Foundation, the same organization behind Kubernetes. It's well adopted within the community. It was actually originated as an internal tool from Spotify, and then they donated it to CNCF back in 2020. It has a mascot called Bowie the Beaver. And most importantly, it has its own conference. So they have Backstage Con, and I think Backstage Con is tomorrow at Amsterdam, the Netherlands. So yeah, that's pretty cool. So let's walk you through what it looks like when working with Backstage. So this is the overall portal that Backstage provides you. They have this list of components which you can consider like for example a microservice or maybe a standalone runtime in its individual instance, right? You can filter through these types of pre-configured filters. You can filter through the Kubernetes namespace. You can filter who is the owner of the service. Is it team A, team B, or from the growth team? You can filter what kind of component it is. Um, I think you can actually filter through life cycles if it's in a production environment or in a non-prod environment. Again, you can filter through owners and all of those things. You can filter through programming languages if you set tags through it. And you can easily search through, for example here, if I click to this particular component, I can have like a visual representation of which team owns this and what are the other dependencies or other parts of this service. So if I click through Team B, I can look through who are the members of Team B, and I can go ahead and message them through Slack and ask them some questions, and the other components that this team has. Other than that, there's also some other metadata that I can look through in this portal. You can hook up CI/CD for this, so all of that will be in a single um, uh, in a single UI, documentation, dependencies, things like that. And you can also have links to the GitHub repository that this particular service um, references, right? So yeah, that's pretty much the power of this catalog. There are other features of Backstage. For example, you can centralize all of your open API documentation in Backstage. Just provide it with the URLs, and it will give you the open AI in a centralized place. So here, um, as you can see, there's a bunch of open API Swagger documentation here. You can just provide the links, and it will be there ready for experimentation. It can centralize all of the docs for you. So you can, let's say, have like a WYSIWYG interface, and it will store those documentation in like a README file, and it will display that right here. You can also explore through things such as um, this tech radar thing. So it summarizes all of the tech that's adopted in your organization and guides through decisions on what to adopt in the next service. And it has this interface for cost reviews. If you have like a really good FinOps process in your organization, you can integrate it with this and a GraphQL API for if you're using GraphQL. So this is not all of the features that Backstage provides, but it's one of those that are pretty useful for all organizations. So let's try to set up Backstage, right? Backstage is actually more focused on the TypeScript side of things. So to really start with it, you just run this npx backstage create app latest. It will download a bunch of scaffolding files, and all you have to do is run yarn start. So let's walk you through the insights, what's inside of this scaffold. So as you can see here, there's this src folder with a bunch of TypeScript files, right? And aside from TypeScript files, there's TSX files. So essentially, Backstage is a React framework for internal developer platforms. So you can create your own components, create your own visual styles, things like that, and a bunch of routes that you can look into. There's also this folder for backend for plugins. Backend is mostly the folder that you use to configure stuff. If you, for example, if you want to add another plugin into the system, there's this app config YAML for setting things up like OIDC, for connecting to your cloud provider or connecting to GitHub, things like that. But the meat of the whole configuration of Backstage really is in this catalog folder, right? So if we look inside this or these manifest files, if you can see, they're pretty familiar, right? They're similar to Kubernetes manifests. So if you look into this template, we're actually defining what we call a template here. So a template is a way for us to scaffold a pre-configured configuration of an environment. So for example here, this is a template for a new Python service. So we have defined here some fields, name, description, namespace, port. So we've instructed Backstage so to collect these fields, all right? And these fields have these restrictions. It has this regex pattern. We're gonna ask for the description, the port for it, the route path for it, and then a bunch of other properties like the name of the repository we want to put this in, right? So it will collect all of those data that we want this service to be created at, and it's gonna perform some steps. So in this step, it will call this action a predefined action in Backstage called the fetch template, which actually references this dot content folder within this whole repository. So if we look at this dot content folder, it's over here. It's pretty much a Python service template. It has tests, it has an SRC folder, a GitHub Actions folder, pretty much a template for spinning up a new Python service, right? It has a rough setup, it has PyLint, all of that. And then we're gonna publish that to GitHub. So we're essentially going to create our very own repository from this. After that, we're going to um, create the Kubernetes manifests to deploy this to Kubernetes. So we've also predefined the URL, like the folder directory of where these manifest templates will come from. So it's in this K8's manifest GitOps something something. So that's pretty much all of the templates, and it's all template. It's all in a template language that we can reference. So that's that. No? What's next is we're going to create a PR, like a PR to the infrastructure repository to go ahead and request for review to the DevOps team, for example. So this PR will collect the data, the data that was the Kubernetes manifest files that we've generated, and put that into something for review. And this repo is a predefined one. I called it CDK EKS infra. And we're just gonna, after that, we're gonna register that into our service catalog and push a notification team to a Slack channel, for example. So that's the definition of what we are trying to achieve. Let's see that in action. So here I'm in Argo CD, nothing much here, just checking the current services, the apps that I have right now. And if I skip through a bit, I should see, this is the current repositories I have in this organization. So here in my local Backstage instance, we now see this template. In this template, we're gonna call a new service. We're gonna create a new service, which should be just a fast API, PyTest, rough, standard service. We're gonna call this I love Python, right? Description, I love Python, pretty much the same. Load balancer path. So after this service will be deployed, this will be accessed to the slash I love Python prefix. And after that, we're gonna define what we're gonna call the new repository for this service. So it's pretty much the same I love Python. So let's hit create. So note that all of this workflow is defined through the manifest that we've showcased earlier. So it's going to publish to GitHub, gonna create the GitOps PR shortly. Yeah, and it's going to, and just like that, all of it is done. So if we click, it just created this new GitHub repository just now with an initial commit and all of the CI/CD running. And all of that is scaffolded with the predefined template. Okay. Other than that, we have also done something like create the GitOps PR. So if we go to this, it has created this pull request to the CDK EKS infra repository, which is the pretty much the repository for the Kubernetes cluster, and all of these manifests ready for deployment. So that's the deployment, the service definition, the templating for customization, all of that. So what we're gonna do now is to wait for the CI of the I love Python repository to upload to our container registry, and then merge that PR. And we're gonna showcase how that's gonna be deployed now. So right now it's loading. Let's just skip through this, assuming that it will take a pretty long time to upload. So just gonna skip through this and assume that by the end, yeah, it's finished. So let's assume now that it's already uploaded into ECR. So all I have to do is merge this. Rebase and merge. All right. So it's now in the main branch, and all we have to do now is wait for Argo CD to kick in. So here we're in Argo CD, pretty much, and if we refresh long enough, we see the new I love Python dev pod already set up here. And if we go to the prefix I love Python, it should now show the new service that we have just spun up. So here I love Python health directory, and it's now live. So all of that, imagine if you were a dev like Maya, all you have to really do is fill out the form in Backstage, and all of that will be deployed into your configuration that you have set up. So that's the power of Backstage, right? So the goal is not to remove all of the complexity. It is to make the right path obvious and repeatable for the developers. And it has a really rich ecosystem of plugins, things like for your that are specific to your cloud service provider. It has a pretty rich ecosystem for other clouds as well. So that's the whole promise of a golden path, right? So that golden path already chooses the metadata, the CI/CD, and it triggers infrastructure for you. However, the real a problem here is when a broken template occurs. So it doesn't just affect one service; it affects countless dozens of services that might have derived from this template, and you might experience something like burnout from multiple Slack messages from different teams that consume this template, right? So there's this anti-pattern of treating templates like static YAML. So you don't just edit it casually and then test manually and hope for the best. You have to treat these templates as code. And since it's code, it should be tested. So right now, we are going to walk you through how to really test this Backstage templates using what we call a Python harness that we've created internally within our team. So I'm going to showcase this one here. We've created this module called Template Tester. So what it pretty much does is we went through the documentation of Backstage. We crawled through pretty much all of the internal APIs that it uses it, and we mocked all of these internal APIs so that we can test them in our local environment. So we have this scaffolder client, and I think we also predefined some tests from here. Sorry. And we define these validators for validating different parts of our Backstage instances. So we want to validate if these files are created correctly, if they are correct, if they are created in the correct path, if they have the correct contents, if they have called a particular API that we have depended on, right? And from that, we can now create a test suite for this with just PyTest that depends on this template tester module. So putting this in action, we can just run PyTest on the entire test suite that we have pre-configured. And let's say, for example, we want to simulate a drift. We want to change the path of this module, and now it throws an error. So imagine like a platform team that continues to work on several templates all at once. We want to make sure that nothing breaks and all of it is still has the same DevOps principles as we have. So imagine that a platform engineering team is still a software engineering team, but the customer is your internal developers. All right. So let's now go back to Maya. Think of the same Monday, but instead of her searching for these examples, searching through the APIs, scouring through all of the Slack channels, all she has to do is pick a template, inherit the default ownership metadata, get the docs and CI/CD all in one place, use the pre-approved security guardrails for that template, and all she has to do is focus on the feature itself, the differentiated heavy lifting. So it actually shifts the landscape of going from documentation standards to enforcing the standards in the code itself. We shift from hoping the template works into proving it works with the test-driven approach that we have added with the Python harness. And instead of relying on tribal knowledge on what is the standard for every type of service that we create, we now have repeatable validations to these templates that we have configured through tests. So the outcome is essentially trustworthy, which is essentially a trustworthy, dependable golden path for happier developers. Okay, so that's pretty much it for my talk. Here's my QR code for all of my channels. So feel free to reach out, and thank you.
Thank you so much, Sir Jan. Does anyone have questions? Questions from anyone? Sir Jan, do you have anything else to share? A question.
Interesting talk and tool. Just curious on what's so it's kind of like to improve developer experience and developer compliance basically. But what's the minimum developer count or team count for this to be implemented? For this implementation to be worth it?
Yes, yes. Okay, good question. So, I'd like to think of it not as the minimum number of developers, but the pain points that these developers have experienced while going through the countless number of services that they have in the organization. So, if, for example, you're the developer like Maya who has these issues with um, working through documentation, finding the discoverability of these things, and figuring out the correct template, then that's the point where you have to pitch to your stakeholders, and we have to really implement a platform to abstract all of these things for us. So I think that the threshold would be if the amount of cognitive load for your developers would be so immense that um, it prevents them from focusing on the actual product, then that's where you're going to consider developing a platform. But otherwise, then stick to your traditional processes. Document things really well, and yeah, try to make standards really standard. So the short answer is it depends.
Do we have other questions?